Welcome my colleagues and my dear students. Today we are speaking about propagation of nerve impulse. In the previous video we spoke about the action potential and we defined the action potential as a potential change that occurs in the nerve as a result of stimulation by effective stimulus. And we said that the action potential propagates along the nerve and reach the effector organ and produce action. So it is called action potential or the nerve impulse, which is responsible for all aspects of human life. It is the official message inside our body between different organs. Regarding the structure of nerves, we have three main types. First, type A, then type B, then type C. Type A is thick myelinated, type B is thin myelinated, type C is non-myelinated. And from a functional point of view regarding the process of impulse transmission, we can divide the nerves into myelinated and non-myelinated. Type A and type B, they are myelinated, while type C is non-myelinated. The impulse propagates along nerves. We have two main types of propagation. Propagation in the myelinated fibers and propagation in the non-myelinated fiber. As we know, myelinated fibers are covered by myelin sheath, which is interrupted by what is called nodes of Ranvier. They are spaces within myelin sheath. However, non-myelinated fibers are not covered by myelin. So we have two main types of conduction or propagation along nerves. Continuous conduction, which occurs in non-myelinated fibers, and saltatory or jumping conduction, which occur in myelinated nerves. First, regarding the continuous conduction, we have to transmit impulse from one point to another along the surface of the nerve. All points over the surface of the nerve fiber have to depolarize, so it needs too much time and consumes too much energy. However, in saltatory conduction, the process of depolarization is restricted only to nodes of Ranvier, so it consumes less energy and it is much faster. The velocity in the continuous conduction is from half to 2 meters per second. However, in the saltatory conduction, it may reach 120 meters per second. It is very fast regarding the continuous conduction. The process of conduction is similar to these domino pieces. While you need to disturb this long line of pieces, you have to disturb only one piece, and every piece disturbs the next, and so on till the end of the line. Also, during impulse transmission, we have to stimulate only one point. Then this point stimulates the next, then the next, till the end of the nerve. In continuous conduction, when we stimulate by effective stimulus, impulse is generated at point 1. Later, this creates a potential difference between point 1 and point 2. This circle of currents causes depolarization of point 2. Then the process repeats itself between point 2 and point 3, then from 3 to 4 and so on. However, we need too much time and need too much energy because in continuous conduction we have to depolarize every point on the surface of the nerve. However, in saltatory conduction we have to depolarize only the nodes of Ranvier, so it consumes less energy and it is very rapid, and the velocity may reach up to 120 meters per second. Whenever we stimulate by effective stimulus, the process of depolarization occurs in the first node of Ranvier. This creates a potential difference between this point and the neighboring point. A current is formed that results in depolarization of the neighboring node. Then the process repeats itself between the newly depolarized area and the next or neighboring node and so on till reaching the end of the nerve. As we said, this process needs less energy and it is very fast. That is all. Thank you and see you again in next lecture.